Today let's talk about mathematical physics. It is very important chapter nowadays, especially because of data science. If you are in your PhD level or if you are in your research, the scientific field, if you are in a business analysis, you are in any field, we have mathematics. So that here are some table contents you might look at here. You can see here the tensor analysis, and you might be wondering that where exactly we are gonna use them, what the uses of them in our real life. You might have question in your mind, the frequently that is what happening in your mind, why we are going to study all these things, even if they are not a new theory, they are already derived by many mathematicians. They are very useful in our real lives. You can see the data science everywhere. Without the mathematics, it cannot walk even one step ahead. Data science, the everything we analyze, or suppose we are in a scientific research, we need to use different the tools to know about the system, to get insight or knowledge from any system, after extracting and clearing a data, cleansing a data. All right, how to do? Here are some mathematical knowledge which are very essential to do this, are given here. You can see here tensor analysis. This tensor analysis, when you listen the term tensor analysis here somewhere, at the time you understand that this is transformation of some quantities which are independent of a coordinate. You are going to change one coordinate system to the another coordinate system, and there is no change in the set of quantities. Then we can say tensor analysis. You are in your curve linear system. All right, you wanna go into linear coordinate system or cylindrical coordinate system. Your quantities, whatever the physical quantities are here, set of quantities, they are not going to change. The even if there is change in coordinate system, then we can say tensor. We analyze these all quantity. How can we calculate them? We calculate all these in the days to come. And in the linear factor analysis, you might add, subtract, and different the operation you may do there to know about the vector, more than two vector, when they're in your system, how they're acting, and what the insight they're giving after their operation. Sometimes they're added, sometimes they're subtracted. What would we do? What the system we get, we analyze in this one. And in the group theory, you can see the natural number, whole number, different other integer, the rational, irrational, everything we can see there. What we get, the when they're added, they're subtracted, when we have a binary operation among natural number, among whole number, how do we explain about any the system you have? You can calculate all the nature of the system. If you know the nature of a system, you can know the insight, what the physics into that system, and due to that system, the this system in which you observed is working. If you know that, then you use the same formula in your real life, you can have new invention. In the same way, you can see in the next one, you should here is integral transforms. Integral transform means, suppose you have a differential function. All right, you are taking from one system, you're gonna change its shape, you're gonna change its position, you're gonna change the system into next one. Here are some the change, some tools, I can say tools here. The transform, Fourier transform and a Laplace transform. Either of them are very important, but any one of them you may use whichever would be fit in your system to transform your integral. Alright, some might use this Fourier transform. You have a sum system in it, and likewise this one Laplace has also its own system which gets transformed any integral into the next one. In this way you analyze the system. And another in fifth one, all right, here is in fifth one is differential equation. Differential equations means if some quantities, that they are going to change with respect to some quantity, how they're going to change with respect to the next one. We want to get if in any equation, then we must use this differential equation. That means change in system if we have, then we might understand the system is going to change in this way, and we can filter inside knowledge what is in the system, and we can get formula and use in our business, in our research, in our the daily life. And in sixth one you can see the Sturm-Liouville system. Sturm-Liouville system is the system which is used to the solve ordinary differentiation or partial differentiation. The ordinary differentiation means the differential equation which is taken with respect to the change in one variable. Alright, and partial differentiation you can see here, it means this system has more than two variables. With respect to these more than two variables, system is going to change. At that time what we should do is here we must use partial differentiation equation, the techniques to solve this one to get a value. Alright, another you can see the Green's function. If you have a inhomogeneous differential equation, at that time you should use Green's function, alright, to solve this function. When you have a problem of one source, the one point source which is in a structure of a point, you can see the point. If you want to analyze the point system, at that time you must use Green's function. Alright, so that inhomogeneous systems are explained by the Green's function. Let's get started about this first one, tensor analysis. I'm going to change this slide. Look at here, what is the tensor? Alright, tensor, you can see here the tensor. I have written some the introduction of this tensor. Alright, what the tensor is: physical laws. There are physical laws means which we can measure. The physical laws must be independent of any particular coordinate system used in describing them mathematically. Whatever the, no matter the coordinate system is there, the physical laws, they're independent. And if we want to describe them, that means this physical law mathematically, at that time it doesn't talk about the physical laws. They doesn't talk about the coordinate system. There might be curvilinear coordinate system, spherical coordinate system, cylindrical coordinate system, whatever the coordinate system is. At that time, and the physical laws are that they are independent. And if they are valid, this physical law must be valid. At that time they are independent. And here a systematic behavior of investigating behavior of a quantities. You are going to investigate the behavior of a quantities. You might have any quantities. You have a force, you have energy, you have a velocity, you have everything, momentum. Alright, you are going to investigate the nature of the system or behavior of the system. That system that undergo coordinate transformation. Alright, at that time what you should do is tensor analysis of that subject of matter. If you want to get the systematic behavior of any quantities, at that time what you should do is tensor analysis. Alright, and in this way we can say that tensors are the quantities obeying certain transformation. You should transform the tensor. That means these are quantities which can have the certain transformation. All right. Here a tensor consists of set of quantities. Whatever the set of quantities tensor consist, we call the components, and these components are properties. These components properties are independent of the coordinate system used to describe them. Suppose you have this x y z. The r is the position vector. You are going to analyze this one. It is not depending on the coordinate system. Whatever, no matter what you are going to take, the coordinate system is there. All right, you are going to change quantities, and these quantities are called the tensor as well. And here you can see the components of the two different coordinate system are related by the characteristic transformation law. The two different coordinate system. That means you might take the any coordinate system. I have already told spherical coordinate system, cylindrical coordinate system, curvilinear coordinate system. The curvilinear, here is curvilinear coordinate system. At that time, this system has the transformation law, and on the basis of this transformation law, this coordinate system, these any two coordinate system, they are interrelated, and from one coordinate system to another coordinate system. That means they are interrelated. Let r x y z be the position of the vector phi. The same like you have done in your VSC classes, in your +2 classes, and this is the position. And another one is here, the point P satisfy the coordinate transformation to the u1 x comma y comma z, u2 x comma y comma z, u3 x comma y comma z, where u1 u2 u3 are curvilinear coordinates related to the P. You can see the figure as well here. If we take the partial derivative of it, we can write this way: dr equal to here is vector. You can see I haven't written here vector. It doesn't mean here isn't vector, here is vector. I forgot to write here at vector. Right, in all the r you can see here on the above of this r, you should write r vector. And if we want to take the partial derivative of dr, we should do this way. And the unit tangent vector, you can see these are tangent ta. Sorry, here I have written e, here shouldn't be e. Tangent vector means unit vector. You can see here d e1 e2 e3. I can write here cap, all these are taken, the cap. On the stage of cap, you can take the cap on their head, because unit vector are always represented in the form of a cap. You know it from your class 10. The all unit vector are represented by cap. And the figure you can see here, this is a point phi, which is the r1 u1 u2 u3. In this way, this system is here. You have, this is curvilinear coordinate. All right, curvilinear means this is in a curve. You can see these are in a curve, and all these are in a curvilinear coordinate. At that time, if you have a point P here at, how can we write? I have written here this way. You can see u1 is c1. C1 means this distance you can measure. C2 this curve is. C3 this curve is. If you write this way, then you can understand about what is happening inside this curve. Alright, your aim is to know what the function is working in this curve, okay, in this area. If you understand about such specific set of quantities, you can analyze the system and get insight, knowledge, and use to get some knowledge or extract some knowledge from it. In this way, the data science, the one of a demanding, the professional nowadays. That's because of data sets. That's because of mathematics. We can get everything. We can get the knowledge how the system is working. All right, in this way. I will explain in a detail in the days to come. Thanks for your time. Obviously, you like my video, and if you comment, subscribe, obviously I get some confidence. And in the days to come, I'll upload great videos so that you can get a knowledge. All right, so don't forget to hit the subscribe button down below. Thank you for your precious time.